7 ghost gray stealth bombers are crossing into Iranian airspace. Iranian radar is dark. Iranian air defenses are silent. Not because they stood down, but because they never even knew the planes were there. Each bomber is carrying 2 bombs. Each bomb weighs 30,000 pounds. Each bomb is about to be used in combat for the very first time in history. The target is Fordo, Iran's crown jewel, a uranium enrichment facility buried inside a mountain 260 feet of solid rock overhead, designed by Iranian engineers specifically so nothing on Earth could touch it. Iran spent decades and billions building the perfect underground fortress. They'd watched what happened to Iraq's bunkers in the Gulf War. They were not going to make the same mistake. So they dug deeper. 14 30,000-pound bombs fell anyway. The mountain didn't care. The concrete didn't care. And Iran's dream of an untouchable nuclear program cracked the way most dreams end when physics gets involved. Badly, suddenly, and with a lot of smoke. And the punchline? The bomb that hit Fordow is already being replaced by something worse. To understand how you build a bomb that kills a mountain, you have to understand why every bomb before it failed. Drop a conventional bomb on reinforced concrete, and most of the energy sprays upward and outward. The structure shrugs it off like an afterthought. The concrete wins. So the question became, what if the bomb didn't fight the concrete at all? Barnes-Wallace understood something different. Concrete is strong under compression, squeeze it and it holds. But stretch it, flex it, vibrate it, and it cracks apart. So instead of designing a bomb that would smash through a bunker from above, he designed one that would burrow deep into the earth beside the bunker and then explode underground, creating a massive cavity that collapsed the structure from below. He called the effect a camouflage. The British press called his bombs the earthquake bombs. Then came the Disney bomb. Yes, that Disney. Because a group of British naval officers reportedly got the idea watching a 1943 Walt Disney propaganda film. Officially, it was the 4,500-pound concrete-piercing rocket-assisted bomb, and it solved the core flaw in every bomb before it. Instead of relying on gravity alone, it used 19 rocket tubes attached to the rear that ignited mid-fall, accelerating to Mach 1.29. 990 miles per hour. A single Disney bomb penetrated 15 feet of concrete at a German submarine facility and kept going, blasting through the floor and ending up in the sand underneath. Nobody planned for that. The facility's engineers certainly didn't. The Nazis never built a bunker strong enough to stop it. Iran was paying attention. Operation Desert Storm. The US Air Force is staring at a problem. Iraq has buried its command centers under multiple meters of hardened concrete, and the existing 2,000-pound bunker busters are bouncing off like rocks thrown at a bank vault. The solution they built is almost offensively American in its audacity. Engineers pulled 8-inch howitzer barrels from military stockpiles, welded them into bomb casings, filled them with 675 pounds of tritonal explosive, a TNT and aluminum powder mix that's 18% more powerful than standard TNT, added a laser guidance system so it could home in on targets lit up by ground spotters, and called it the GBU-58. The whole thing was done in 28 days, not 28 months, 28 days. On February 27, 1991, 2 of these were dropped by F-111 Aardvark jets. One missed. The other punched through a heavily fortified Iraqi command bunker, and smoke started pouring from the entrance. Within 48 hours, Iraqi forces surrendered. The GBU-28 could penetrate 20 feet of reinforced concrete and reach 100 feet into the earth. Then Iran started building with something the GBU-28 was never designed to handle. Iran didn't watch what happened in Iraq and panic. They studied it. And what they concluded was that the problem wasn't depth. It was material. Existing bunker busters worked because traditional high-strength concrete has a yield strength of around 5,000 to 10,000 pounds per square inch. Strong, yes, but brittle. Hit it hard enough in the right way and it shatters. So Iran adopted something different: ultra-high performance concrete, UHPC. a composite material reinforced with high carbon steel fibers and glass fiber, giving it a yield strength of up to 35,000 pounds per square inch. Here's the key difference. UHPC doesn't shatter under impact the way traditional concrete does. Instead of catastrophic failure, it develops a network of tiny fissures that absorb and distribute energy. In the late 2000s, reports began circulating through US military intelligence that an Iranian bunker had been struck by a bunker buster bomb. And instead of penetrating, the bomb had become embedded in the surface. UHPC had apparently stopped it cold. That story sent shockwaves through Pentagon planning circles because it meant a $15 million precision-guided weapon had essentially been turned into an extremely expensive paperweight. Iran also went vertical. Rather than building bunkers under flat ground, they put their most sensitive facilities inside mountains. Fordo is the prime example, carved into granite rock under 260 feet of natural coverage, designed to make even the deepest conventional penetrator irrelevant. At those depths, the original GBU-28 was completely useless. Iran had essentially made the existing arsenal obsolete, so the Pentagon did what the Pentagon does when something stops working. It spent $15 million per unit on something that would. The answer the US built is called the GBU-57 Massive Ordnance Penetrator, the MOP. And describing its specifications is an exercise in absurdity. It weighs 30,000 pounds, 20 feet long, 32 inches in diameter. The casing is Eglin steel, an alloy so strong it's more than 6 times harder than construction-grade steel, specifically chosen because it needs to survive punching through a mountain before it explodes. It carries 5,300 pounds of explosives inside a 6,000-pound warhead. It's guided by GPS to within meters of its target, and it can penetrate 200 feet of earth or 60 feet of ultra-reinforced concrete before detonating. For scale, 60 feet of ultra-reinforced concrete is about a 6-story building made entirely of high-grade concrete with no floors or windows, just solid mass. The MOP goes through that, then explodes. The only aircraft in the US arsenal that can carry it is the B-2 Spirit stealth bomber. Each B-2 carries exactly 2. The entire fleet of 20 bombs before Midnight Hammer cost the US government over $300 million at $15 million per unit. Iran spent decades building the most protected nuclear facility on the planet. The US responded by building a bomb that weighs as much as 4 adult elephants, specifically to reach it. Different countries, different priorities. And even with all of that, what happened at Fordo was not entirely what the Pentagon told the press. The operation that would later be named Midnight Hammer began with 7 B-2 bombers departing Whiteman Air Force Base in Missouri. More than a third of the entire B-2 fleet in one mission. They flew for 18 hours continuously, refueling 3 times midair. No communication. Families were told on the evening of June 21st, around the same time the rest of the world found out. Before the B-2s reached Iranian airspace, F-22 and F-35 fighters entered ahead of them to suppress air defenses. Iran's S-300 systems, their best air defense, did not engage. Whether they'd been already degraded by Israeli strikes over the previous 9 days, or whether their operators simply couldn't detect the incoming stealth aircraft, or whether somebody made a strategic decision not to fire, that's still not publicly confirmed. What is confirmed, not a single shot was fired at the American strike package. 6 B-2s hit Fordo, dropping 12 MOPs total, 2 per bomber, directly onto the ventilation shafts of the facility, targeting them sequentially. The tactic was intentional. The first bomb blew off the concrete covers that Iran had tried to hastily cap with concrete slabs in the days before the attack. The subsequent bombs drove successively deeper through the exposed shafts. A 7th B-2 dropped 2 more MOPs on Natanz. A submarine simultaneously launched more than 24 Tomahawk cruise missiles at Isfahan. The official US assessment, extremely severe damage and destruction at all 3 sites. General Dan Kane, chairman of the Joint Chiefs, called it flawless. President Trump went further, saying the sites were completely and totally obliterated.
As you know, their sites were obliterated. They're very evil nuclear sites. Has been proven. We had some fake news for a little while.
A phrase that aged slightly awkwardly when the New York Times reported, citing a senior U.S. official, that Fordo had been severely damaged but not destroyed outright. The truth is probably somewhere in between, and both sides have strong reasons to spin it. Iran wants to claim resilience. The US wants to claim total victory. What independent analysts at the Institute for Science and International Security concluded from satellite imagery was closer to Iran's centrifuge enrichment program has been effectively destroyed. The program has been set back significantly, but some nuclear material and equipment survived, and its location is uncertain. Over 400 kilograms of uranium enriched to 60% purity is still unaccounted for. 14 30,000-pound bombs hit those sites. The mountain craters are visible in satellite imagery. Several tunnel entrances were sealed with dirt and debris. Iran had tried to backfill the shafts with soil in the days before the strike. It didn't help. The fortress Iran spent decades and billions building held up better than the Pentagon's optimistic press releases suggested. It held up far worse than Iran needed it to. Here's where the story takes a turn that neither side anticipated. After the strikes, the U.S. Air Force discovered it had a problem. It had used 14 of the GBU-57s in one operation. Estimates of the remaining U.S. stockpile range between 6 and 15 bombs. That's the entire inventory of the most powerful conventional weapon on Earth. Roughly the number of bombs needed to arm one B-2 flight, maybe two. The Pentagon quietly submitted a $123 million emergency request to restock, because apparently nobody had planned a contingency for actually using them. In February 2026, the Air Force awarded Boeing a sole source contract because Boeing is the only company that can build the MOP. They own the intellectual property on the critical tail kit guidance system. Nobody else can make it. Delivery of replacement bombs isn't expected until January 2028. So right now, as of today, the US has a window where its deepest bunker defeat capability is running at sharply reduced inventory, while the production line spins back up. It gets better. One of the MOP's key guidance components had quietly gone obsolete, and nobody noticed until they actually needed to build more. The Air Force's solution was to reverse engineer it from ATAC-MS ballistic missile technology, pulling a spare part from a completely different weapon system because no one had planned for the MOP to actually be used this fast. The GBU-57 is already being replaced by its successor, the Next Generation Penetrator, or NGP. It will weigh under 22,000 pounds, hit within 2.2 meters of its target even when GPS is jammed, and, most critically, be launchable from standoff range, meaning the bomber never has to fly directly over the target. On March 26th, 2026, just weeks ago, something happened at Redstone Arsenal in Alabama that most people missed entirely because it didn't involve a 30,000-pound bomb or a stealth bomber. A small attack drone delivered a lightweight warhead called Breaker, bunker rupture and kinetic explosive round, and detonated it inside a test bunker. The entire program went from concept to live fire in 2 weeks, not months. 2 weeks. The Army's Picatinny Arsenal team used 3D printing and rapid prototyping to build, test, and demonstrate a drone-delivered bunker buster in 14 days. The significance isn't the warhead itself. It's not going to crack a mountain. For the first time, a grunt with a drone could crack a hardened target without waiting for a B-2 to fly 13,000 miles. The B-2 costs $2 billion and needs a 13,000-mile round trip. The drone costs almost nothing and fits in a backpack. It is, to put it plainly, the bunker buster going democratic. And if you're Iran or any country that has built its defensive strategy around underground architecture, that is a deeply uncomfortable development. Iran isn't completely helpless here, and that's actually what makes this interesting. The most obvious move is shooting down the aircraft carrying the bomb. Iran has Russian-made S-300 systems and some domestic air defense capability. They didn't fire a single shot during Midnight Hammer. Whether that was a capability failure or a political decision is academic. The outcome was the same: Either way, Iran's most expensive air defense system spent that night doing absolutely nothing, which is a very expensive way to do absolutely nothing. The second approach is intercepting the bomb mid-flight. The MOP is GPS guided, which means in theory electronic warfare jamming could be used to degrade its accuracy. Iran does have electronic warfare capability, but the NGP is being specifically designed to hit within 2.2 meters even in GPS denied environments, which is the US directly designing around that countermeasure. The third option is dispersal and deception. Move the most sensitive equipment out before a strike. Iran reportedly did this before Midnight Hammer. Intelligence suggests some nuclear material and centrifuges were relocated in the weeks before the attack. But you have to know the strike is coming, you have to know where it's coming from, and you have to move an entire industrial-scale enrichment operation without being detected by satellite, human intelligence, or signals intelligence. Iran has been trying to pull that off for 2 decades. The location of over 400 kilograms of 60% enriched uranium is still unknown, which cuts both ways. Yes, Iran preserved some material, but the fact that the international community can't find it is a proliferation problem, not a victory lap. The fourth option is hardening further. Better concrete, deeper facilities. Iran has been doing exactly that for 30 years. The NGP's advanced fusing systems are designed to sense depth and chamber geometry before triggering. So the deeper Iran builds, the smarter the bomb gets about when to go off. Iran built the most sophisticated underground defensive infrastructure of any non-nuclear adversary the US has ever faced. UHPC, mountain geography, layered air defense, dispersed facilities, years of preparation. And on a single June night, 7 stealth bombers flew across the world, dropped 14 bombs, and changed the assessment of Iran's nuclear timeline by somewhere between 1 and 2 years. The bomb doesn't have to be in the right place all the time. It only has to win once.